Good morning. Today, we are going to see the problem on symmetrical components and how to draw the phasor diagrams. Sometimes in 10-mark question, they may ask this how to draw them because symmetrical components currents already you know how to calculate the symmetrical component currents. But we didn't see the problems on phasor diagrams. So phasor diagrams with the phasor diagrams, they may ask this kind of question in the 10-mark question. Take down this problem. The current flowing in the line towards a balanced load current in delta R, IA is equal to 100 at angle of 0 degree. IB is equal to 141.4 at the angle of 225 degree. And IC is equal to 100 at the angle of 90 degree. Find the symmetrical components of the given line currents and draw the phasor diagrams of the positive, negative sequence line and phase currents. So what they told is they want to find out the symmetrical components line currents, and as well as we need to find out the phasor, and we need to sketch the phasor diagrams of the positive and negative sequence of the phase currents. So what is given in the problem? IA is given, that is 100 at the angle of 0 degree. IB is given, that is 141.4 at the angle of 225 degree. And IC is also given, that is 100 at the angle of 90 degree. Here, the symmetrical components of current. How to calculate the symmetrical components of current? Already we have seen. So that also I will give in the description, that video, recorded video. That is IA naught, IA positive, IA negative matrix is equal to 1 by 3 into 1, 1, 1, 1 IA A squared, 1 A squared A into IA matrix of IA, IB and IC. This we already derived. So here, while multiplying, you will get the answer as IA naught is equal to 1 by 3 into IA plus IB plus IC. That is nothing but 1 divided by 3 into what is the IA value? Just substitution. 100 at the angle of 0 degree plus 141.4 at the angle of 225 degree plus 100 at the angle of 90 degree. Just we need to add all these things and we need to divide it by 3. Take your scientific calculator, calculate it, and you make divided by 3. You will get the answer as 0.007 at the angle of 45 degree. Next, IA positive. IA positive is equal to 1 by 3 into IA plus A into IB plus A squared into IC. That is nothing but 1 by 3 into this IA what 100 at the angle of 0 degree plus A. A already I said 1 at the angle of 120 degree IB. So IB given in the problem as 141.4 at the angle of 225 degree plus A squared. A squared what? A squared means 1 at the angle of 240 degree. That already in the previous formulation we have seen. Next IC. IC given in the problem, that is 100 plus 100 at the angle of 90 degree. Just take your scientific calculator, simplify it. You'll get the answer as in the complex format like this. So you need to convert that into polar format. If you convert into polar format, you will get the answer as 111.528 at the angle of minus 15 degree. Next, IA minus. IA minus equal to 1 by 3 into IA plus A squared IB plus A into IC. How this equation comes means if you multiply this matrix, you will get the equation like this. Same thing that already we derived. So 1 by 3 into IA plus IA squared IB plus IA into IC. So what you need to do is you need to substitute. IA is 100 at the angle of 0 degree given in the problem. A squared is 1 at the angle of 240 degree into IB. IB what? So IB is actually here into, they wrongly given us positive plus. So this is into. Okay, you just make it correctly. So into 141.4 at the angle of 225 degree plus IA. IA means 1 at the angle of 120 degree. Next IC given in the problem as 100 at the angle of 90 degree. Just take your scientific calculator, simplify it. You'll get the answer in the complex format as minus 7.733 plus J into 28.86. Just convert that into again the polar format. You will get the answer as 29.88 at the angle of 105 degree. Actually, what you need to do is you need to convert this polar format into complex format, and you need to add all the things. And again, you need to convert this complex format into polar format. That is 29.88 at the angle of 105 degree. So you'll get the answer as 29.88 at the angle of 105 degree. Here, again, what you need to do is IB naught. IB naught is equal to IA naught. So IB naught is equal to IA naught is equal to IC naught. That already you know from the previous one. So IB naught is equal to IA naught. That is same answer. Whatever we got 0.007 at the angle of 45 degree, because we got here the answer as IA naught is equal to 0.007 at the angle of 45 degree. The same answer. IB naught also the same answer. Next, IB positive is equal to A square IA positive. So what is A square? This formulation also from the previous equation. So what is A square? A square means 1 at the angle of 240 degree. Next, IA positive. What? IA positive means 111.528 at the angle of minus 15 degree. Just multiply it. You will get the answer as 111.528 at the angle of minus 135 degree. This is the answer for IB positive. Next, IB negative is equal to A into IA negative. So what is A? 1 at the angle of 120 degree into IA negative. IA negative, we already got the answer as this 29.88 at the angle of 105 degree. Just substitute it, multiply it. You will get the answer as 29.88 at the angle of minus 135 degree. Next, IC naught. IC naught is equal to IA naught is equal to IB naught. The same answer, whatever the IB naught, the same answer will come here 0.007 at the angle of 45 degree. Next, IC plus IC positive. IC positive is equal to A into IA positive. Next, A into IA positive means 1 at the angle of 120 degree into IA positive. What? IA positive also we calculate. IA positive here we calculate as 111.528 at the angle of minus 15 degree. Just substitute it. Just substitute it. You'll get the answer as 111.528 at the angle of 105 degree. I think in latest calculator, you can solve this angle polar format directly. But in old calculator, you can't solve this polar format. In that case, what you need to do is you need to convert this into complex format. Again, you need to multiply. Again, you need to convert into this polar form. So in latest calculator, I think you can put the angle also. So easily you can calculate. I hope you are using the latest calculator. So calculation, you will save the time also. Next, IC negative. IC negative is equal to A square IA negative. That is A square means 1 at the angle of 240 degree into IA negative what? IA negative given in the problem. That is minus 7.733 plus 28.86. Just substitute it. Next, you'll get the answer as 29.88 at the angle of minus 150 degree. You tell in the comment like you got the same answer or not. Now, what is given in the problem? The given in the problem is you need to draw the phasor diagram of positive and negative sequence line and phase current. So positive sequence line current first we'll draw phasor diagram for positive sequence currents. So how to draw the phasor diagrams for positive sequence current is this the normal like a general IA positive, IA positive, IC positive. Next IB positive means all at the angle of 120 degree. The phase shift between the IA positive and IC positive is 120 degree. The phase shift between the IC positive and the IB positive is again 120 degree, and the phase shift between the IB positive and IA positive is again 120 degree. So this is the normal phasor diagram, you know. So now with the problem, what is the thing we got is IA positive what? IA positive, what is the result for IA positive? Yeah, IA positive is 111.528 at the angle of minus 50 degree. So this is the reference. This is the reference value we have taken. So with the reference, what is the value we got? 111.528 at the angle of 15 degrees. So 15 degree that is varies by 15 degree. That is minus 15 degree. So minus 15 degree means in this direction you need to draw. So approximately we can draw like 111.528 at the angle of 15 degree. Or otherwise you use one protector and 15 degree approximately you just mark and you just write it as 111.528. Next, what is the IB positive value? IB positive value what? Yeah, IB positive value is 111.528 at the angle of minus 135 degree. Because here you just note down IB positive, IA positive and IB positive, the magnitudes are same. The magnitude of same in the sense here also 111.528, here also 111.528. Only the phase angle only varies. Here minus 15 degree, here minus 135 degree. So minus 15 degree, 135 degree in the sense. Yeah. So 135 degrees with the reference to this same magnitude, and the phase degree is only 135 degree. So you take your protector and you mark from here 135 degree approximately you'll get like this. So here 125 degree means you'll get the angle as 111.528. That is the magnitude, and phase angle is minus 130. So it is in this direction. So 135 degree. So this you mark. Next step, positive, IC positive. IC positive what? 111.528 at the angle of 105 degrees. So here also same magnitude. IB positive also same magnitude. IC positive also same magnitude. IA positive also same magnitude. Only the phase angle differs. Phase angle differs is here plus 105 degree, plus 105 degree. You need to carefully note down plus 105 degree. So with the reference to this plus 105 degree is here. So here it is plus 105 degree, and also the magnitude is 111.528. So plus 105 degree. So now you just take the protractor and you just calculate it. You all will having the same magnitude, that is 120 degree. Here you see this also 120 degree. So 105 plus 15 degree, 120 degree. Here 135 plus 135 minus 15 degrees, 120 degree. Next here you measured here also 120 degree. So phase shift is 120 degree. So this is the normal phase shift, normal like IA positive, IB positive, and IC positive. The phase shift is 120 degree. Here it is slightly varies, but even though slightly varies the phase angle, but even though if you compare all the phase shift, it is 120 degree only. Because if you note down the phase shift between this and this and this, it is 120 degree only. Because you see from here it is 135, but from IA positive and IB positive, it is 120 only. So here also IA positive and IC positive is here again you measure by your protector, it will be again it is 120 degree one. Here also you take one protector and you measure. Here also 120 degree one. So here how to understand this concept means here normally the phase shift is 120 degree, but due to the fault in the positive sequence, that is a change in the phase angle. Here you see minus 15 degree. Next IB positive here is minus 135 degree, and IC positive is plus 105 degree. But even though even though defaultly it is having 120 degree. But only the thing is that this degree somewhat changed. But actual phase degree you measured with the same magnitude and same phase angle, it is somewhat it is deviated. But even though the phase shift between all the three phases 120 degree only, because with the reference if you take that is changing, but a normal phase shift is 120 degree only. Slightly this is 120 degrees, slightly changed like this. That's all. So a normal the phase shift is 120 degree, but due to the fault, the phase shift changes like minus 15 degree, minus 135 degree, and plus 105 degree. If you add all these things, you will get 360 degree or 0 degree. That also you need to observe. Next, we need to draw the phasor diagram of negative sequence current. So normally negative sequence current, what IA negative and IB negative, IC negative. If you see the phase shift between the three phases, it is 120 degree, 120 degree, 120 degree. Next, from the formula, from due to the fault, how the IA negative phase shift changes, that we need to observe. And that we need to observe. What is the phase shift? IA, yeah, IA negative what? IA negative is 29.88 at the angle of plus 105 degree. Next, IB negative what? IB negative is 29.88 at the angle of minus 135 degree. IC negative what? 29.88 at the angle of minus 15 degree. Here, you need to, for verifying the results, it is very clear like all this magnitude should be same and the phase angle only deviates. And the phase angle only deviates. You see, you observe IA negative is equal to 29.88. So here also IB negative also 29.88. IC negative also 29.88. Only the phase angle changes here. Only the phase angle changes here. So you need to like while doing the problem also, you can easily verify whether the problem we are getting the right answer or wrong answer like that. So if you are doing correct calculation with a scientific calculator with no round off like that. So whatever the values comes here that you take, automatically it will give the exact value 29.80. So here similarly we need to draw the phasor diagram for the negative sequence current also. Negative sequence current, how to draw? Yeah, this we have taken as reference. Okay, this we have taken as reference from this IA. What is IA positive is 29.88 at the angle of plus 105 degrees. So with the reference to this, this is plus 105 degree. So we are approximately drawn this as plus 105 degree. So or with the like your protractor also you can draw, or approximately also you can draw. But you just see that three phase should be 120 degree. That you just ensure. So here IA negative is plus 105 degree. What is that? IB negative? IB negative is 29.88 at the angle of minus 135 degree. Minus 135 degree means in the this direction, like a clockwise direction. Clockwise direction you need to draw. So with the reference clockwise minus 135 degrees. So IB negative is equal to 29.88 minus 135 degree. That we also draw. Next, IC negative what? IC negative with the reference IC negative is 29.88. This 28 wrongly mentioned. It is 88. 29.88 at the angle of minus 15 degrees. So minus 15 degree with the reference to minus 15 degree approximately it comes here. Next, you take one scientific is like a protractor and you measure here. This is 135 minus 15 degrees, 120 degrees. If you measure IC negative and IB negative, this is 120 degree one. If you measure IA negative and IB negative, here also 120 degree one. If you measure IA negative and IC negative, here also 120 degree one. So that also you need to carefully observe what is the phase angle between the IA negative, IB negative and IC negative. So with this, like if you minus this automatically, your answer also you verify. 135 minus 115 is 120 degree. Next, 105 plus 15 is 120 degree. Here defaultly this 120 degree only, because is this two are 120 means this should be 120, because as a whole 360. So this should be 120 degree only. If you measure with the like protractor also, approximately it will come 120 degree only. So this is how you need to draw the phasor diagram for negative sequence current and as well as the positive sequence current, and the results also you can verify easily.